Geometry lesson 7-6. Today we want to look at some patterns, and specifically we want to look at what we would call frieze patterns, also known as a border pattern. And if you think about a border pattern, a border is usually something on the outside. So frieze patterns have been around for many, many years. They became very popular back in the Greek days. It's a pattern that extends to the left and the right in such a way that the pattern can be mapped onto itself by some form of a horizontal translation, meaning we're moving towards the right or the left horizontally to match itself on. It can be mapped or fit on top of itself to mimic itself. Now what I mean by it's been around since ancient times, in the Doric theme of architecture, this is basically how most of the buildings were created. If you notice right in this section, we have what we call the frieze, which was right in here. And these bars, these vertical triglyphs, were pretty popular in between each one of the symbols that may have been in the frieze. Sometimes the frieze will repeat the pattern over and over and over again, and other times it changes. For example, we may have a situation where the pattern is somewhat similar, but they're different in between. There's that triglyph again, and it's changing from one to the next. All right? Now this right here would be a frieze pattern as well, although it's not the frieze section of the Doric architecture, but it's still a frieze pattern. It's repeating itself horizontally. Here's an ancient building. You can see most of it has kind of fallen off and weathered, whatever has happened to it over time. You still see the very popular triglyph that's in between each one of the symbols that were there. All right. Also, here's another example. You'll notice that they've changed the picture in between. Now, it may be that these three pictures repeat themselves over and over again, in which case there would be a repeat to the pattern in translation, but again you have your triglyph that's right there. So this is fairly popular to ancient architecture, is our border or frieze pattern. Now we have a few different things to think about. This is the first thing you want to decide when you're trying to classify the frieze pattern. You want to decide whether or not it has 180-degree rotation. In other words, can you take the object, rotate it 180 degrees and have it map onto the next object? And then 180 degrees and map onto the next object? That's a yes or no question. Sometimes it will, sometimes it won't. If you decide that it's yes, these are going to be our possibilities. And I'm going to explain those a little bit further. You could either have TR, TRVG, TRHVG. Those are the only three possibilities you can have if you answer yes to the 180-degree rotation. If you say no, it will not rotate onto itself, then these are your four possibilities. You could have T, TV, TG, and THG. And here's what all those T's and V's and everything represent. Translation is for T. That simply means that the shape just slides and matches up with itself and slides and matches up with itself. R is rotation. That's the first question we asked. You'll notice that R is in each one of these, but R is not down here. So for R, the object is going to rotate and fit, rotate and fit. Horizontal reflection, could you draw a horizontal line and have the object flip over that horizontal line and still match up with itself? Vertical reflection, could you draw a vertical line and have it match up with itself? And then G stands for horizontal glide reflection. Can it slide and flip and still match up with itself? So these are the abbreviations that we're talking about up here. So let's look at a few. This first one, it appears as if we have a wave with a star. And the wave with the star, here it is. I'm first going to decide whether it has 180-degree rotation. If I spin it, it does not seem to match up with any of the next patterns that we're looking at here. So I would have to say, according to our question, that that's a no. It does not. So I'm left with T, TV, TG, or THG. So we go back to it. Now I'm looking here. They all have T, and I definitely believe that there's translation in this right here. Yeah, it matches. Yes, it matches. Yes, it matches. So we have translation when we move to the right. What we don't have, if we look at the rest of these choices, can we draw a vertical line and have it reflect over the vertical line? Can we get glide reflection? Can we draw a horizontal line, slide it, and flip? So let's test that out. If I draw a line right here, will this shape ever flip over and land on the shape that it matches with? And the answer to that is no. It will not flip and land. So we do not have a vertical reflection. Could I draw a horizontal line everywhere and have that object flip? Could I have it slide and flip? The answer to that is also no. So out of all of our choices, we don't have any vertical, glide, or horizontal reflection. We only have T. So the only answer that seems to fit is translation. That's the only thing we've got. All right. The next one, we want to ask again, do we have any rotation? Didn't mean to do that. So we take our object and we try to rotate it 180 degrees. So I spin it 180 degrees, and sure enough, it looks like it fits. It's the same. So at that point, we have decided that that's a yes. It does. Yes, it has. So we have a choice between, we know it has rotation. The question is, does it have any other forms of vertical or horizontal reflection? So we'll check on this. Let's draw a vertical line. Can we ever draw a line here and have this object flip over that to the left? If I flip it, nope, it doesn't seem to match up. So apparently that's a no for the vertical. Now let's try the horizontal. If I draw a horizontal line anywhere in here, will this object flip up and down and match up? Nope, not quite, because the tail and the tail don't match up. So apparently it doesn't have either horizontal or vertical reflection. And if it doesn't have horizontal reflection, it's going to be pretty tough to have glide. It's not going to slide and flip. So we're not going to slide this object and then flip it. If I slide and flip it, the tail will still be up on this side instead of over there. So the only thing we have is translation, because the object will rotate over. Now you're thinking, wait a minute, it doesn't have rotation or translation, but it actually does. If you take these two objects, which is a little bit hard to see, but if you take these two objects and you slide them over, they match up. So it has translation. It just doesn't have translation of one object. It has translation of two objects. So the only thing we have is rotation and translation. I seem to be frozen here. Translation and rotation. It's really glitching here. I've never had it do this to me in the middle of a video. It says it's not responding. That's great. Okay, maybe we're back live here. Okay, so we've got TR, because we have translation, and we have rotation. So those are our two. All right, the next object. Do we have 180 degree rotation? So I'll take an object and I'll spin it 180 degrees. It does not seem to match up, so I think the answer to that is no. We do not have rotation. Since we don't have rotation, it's going to be one of these four possibilities. We want to check and see if anything can reflect. So we'll look for vertical. If I draw a line vertically here, will this object flip over and match up? It does not appear to be doing that. It will not flip because those are up and now they're over here, they're down. So we don't have anything vertical. So we go back to our choices. We know it has translation, but does it have nothing vertical? No. So we have to check about the horizontal glide and the glide reflection. So we go back. Will the shape simply flip over and match up with itself? No. It has to slide and flip. Slide and flip. Slide and flip. So we can't just draw a line and get horizontal, so we have glide reflection. So we're going to look at this one and say it's got translation and glide reflection. It's going to slide and flip onto itself. And the last example, we take a look here. Squiggly lines. All right, the squiggly lines themselves don't seem to rotate onto each other at all. So we'd have to say that no, it does not have rotation. If it does not have rotation, we're looking at these four possibilities. So we want to check and see if it has any other reflection amounts. If we draw a line in the middle, this shape will not flip onto itself. So we would have to say that no, I cannot draw a line and have all of this flip onto itself and match up. So that's no good. It's got no horizontal. What about glide reflection? Can it slide and flip? The answer to that, no, it cannot slide and flip. How about vertical reflection? Would this object flip and match up over there? And the answer to that is yes. So we would say over here we've got translation, and you might say again, how does it translate? These two objects can slide and match up with those two objects. So it has translation. And it also has vertical reflection. So we would classify these four freezes, T, TR, TG, and TV, because that's the type that they actually fit. Here's some other examples of some freezes. These would be fairly popular on some rings. You'll notice the continuous wave that we looked at. This pattern seems to repeat itself. Here's a mosaic that has a freeze pattern to it. The circles and the waves seem to translate all the way through. And here's more of a circular freeze, but still the same thing with the wave inside, even the dolphins all seem to fit that freeze pattern. So it's something that has been very popular in architecture for many hundreds of years, and we still today, even our modern Supreme Court buildings and many of the buildings in Washington, D.C. have frieze patterns on them. They are very pleasing to the eye because of the systematic repeating of the pattern itself.